Then
Uh,
what was the next thing we discussed?
Intensive variables
Hmm?
and state functions.
What is it? State function. What do you mean by state function? What is a state function?
Ma'am, entropy and enthalpy. Is it?
Entropy and enthalpy. What is entropy and enthalpy? Abhishek. Entropy and enthalpy is something you're gonna learn this year only. I know you were just reading the slide and right, Abhishek?
No, ma'am, I was not looking at the slide.
Oh, okay. But then what is it? If you're writing the notes. 3 days long weekend, oversleeping. It's not only applicable to Abhishek. I know you. I just got your name and so you are here. It will be more, if I'll ask many, it will be the same thing, right? And some are nodding in the head here. You can't see, but I can see. Right. It's okay, Abhishek, but please make sure that when you're coming next class, like read what we have discussed last class and come. Okay. So state function mean there are different variables, as I said, like which is describing the state of a system. They are known as state function, and the state functions are like basically depends on the initial and the final state of the system. It does not, because we were taking an example of pressure at the ground level, pressure at the top of a hill or mountain. It does not depend on how you climbed on the top of the mountain. It depends only on what is the distance you're covered or you're climbed, right? So pressure is an state function which depends on only the initial and the final state. It does not depend on the route. But work is a path function, because work mean whether you're using a stairs or you are using an elevator to reach the same destination, it varies because the work done in that conditions will be different. So state function mean the function or the variable which depends only on the initial and the final state of a system, and path function mean it depends on the route at which you reach that destination or you achieve that destination. That kind of functions are known as path function. So variables mean something which the variation on that which affect the system. Say example, pressure. For a gas, pressure is an important thing, because if you apply the pressure, the behavior of a gas is affecting. When you decrease the pressure, the gases are more free to move apart. So variables mean, the word variable mean when you're changing, when varying that particular quantity, it is making an effect on the system, whatever the system is. That is what the variable, the symbol meaning of variable. So when we deal with the gaseous state last chapter, we said pressure, volume, temperature and number of moles was basically variables which is related to the gas, because these four were affecting its property. Similarly, for a system which we are undergoing this investigating that system, there are different variables affecting it, right? And we were discussing about the state function among them, that is the functions of the variable which depends only on the initial and the final state. So all the variables of a system, Zuhair, okay, all the state functions of this system is classified as state function and path function, right? State function mean it is depending only on the initial and the final state, and path function mean just like example like work. Work is a very good example for path function which depends on the route, okay? Then again we classified the state function as intensive and extensive. What was it? Anybody? Prasanna, are you there? Prasanna, are you there? Boys, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. What is it intensive and extensive, Prasanna?
Ma'am, intensive means it's like independent of the quality of the substance. And
Quality or quantity?
quantity of the substance. It doesn't matter how much water is there. Like volume is an example of intensive variable, and extensive is depends on the quantity of the substance.
Yeah, quantity, because the pressure or temperature, because boiling point of water, whether you take 1 ml or 100 ml or 1 liter of water, the boiling point of water is 100 degrees Celsius at normal atmospheric condition. So it does not depends on the quantity. So such kind of say state functions are known as intensive. If it depends on the quantity, say example, you can say energy, internal energy, volume, mass. Mass depends on the quantity. So these kind of variables are extensive variables. I think this was the last point we discussed, right? Okay. Any doubt so far? The silence is like,
No, none. No.
okay. Yeah, as it was like after long weekend we are coming, that's why I just recapped everything so that we can go to the next point. So we're gonna discuss about the different state function one by one, and the first state function which we gonna discuss is internal energy. Internal energy. So what does that word indicates? Internal energy. What is it? Energy possessed in the system, or you can say energy associated with that particular system which you are under doing the investigation. So symbol. So if you're not start writing the notes, write the side heading internal energy and write as a key point. The first key point under the internal energy will be the definition: the energy associated with the system is known as the internal energy or intrinsic energy. The another term for the internal energy is intrinsic energy. So this is the first definition. Internal energy is energy associated with the thermodynamic system, because system mean we are dealing with the thermodynamic system. Because as per thermodynamics, what is our system? For that system, what is the energy associated with it? That is what is known as internal energy. As you know that when you're taking a substance based on the state, if it is a solid state, particles are arranged close towards each other. There is no particular gap between them. It's an orderly arrangement. So what happens is like the particle have only vibrational motion. So only motion or the degree of motion available or possible for solid state is vibration. But if it comes to a liquid state, particles can have rotation, can have translation motion. Translation means to and fro, like forward and backward direction. But when you come to a gas state, it is vibration is possible, it is rotation is possible, and there is also translation, but their extent will be more. Not like in the case of a liquid state, not in a definite area, gases are more free. So basically you can say in terms of their movement, the movement of a particle, the different energies can be translational energy, rotational energy, and vibrational energy. So it basically depends on the state. Other than that, there will be electronic energy stored in it. There will be energy because of the electronic excitation. And there could be, if there are some substances which are related to nuclear energy. All of the particle does not have nuclear energy. So it basically they are listed some of the energies associated with the system. You don't have to learn everything, just for your understanding. Internal energy is sum total of all the energies, whatever is stored in a system. So if all of them may not be possible with one system, maybe 3 is possible. For some other system, there will be 5. For some other system, there will be 10, sum of 10 different energy associated with it. So based on whatever the chemical you are dealing with, or whatever the molecule you have taken, what all energies are possible for that particular molecule, That sum of all that energy stored is known as internal energy. So the second definition you can write for the internal energy will be, it is the sum of different energy stored in atom or molecule, because as we are dealing with chemical thermodynamic, our system is basically different atoms and molecule. We are not dealing with physical thermodynamics. So as we are dealing with chemical thermodynamics, our molecule, because that is what our reactants or products. So you don't have to write down all these 7 things. You can just write it as pure example like the translational, rotational, anything. And one more thing to be noted, internal energy is represented with the symbol letter U, capital letter U. So the first point in internal energy will be, it is the energy associated with the system. Second point, it is the sum total of different stored energy of the system. Like it's related to their movement, it is related to their electronic or excitations. It is due to intermolecular interaction, their energies are there, because between the intermolecular interaction, that is also there. But all small energies, if you add them together, what the total energy of the system is represented with the term internal energy. And it is represented by the symbol letter U. Am I clear?
Yes, ma'am.
Okay. Now we have to check how you can prove that internal energy is a state function. How we know that internal energy just depends on the initial and final state? Is it depends on the root, right? So that is what we're going to analyze next. For that, I just need one extra definition, because after knowing this particular definition only, you will understand my explanation. So I'm starting with a small explanation, which is adiabatic process. Adiabatic process. Adiabatic process or adiabatic system means there is no exchange of heat between the system and surrounding is possible, then such kind of process is known as adiabatic process. So it's a thermodynamic term again, it's related to thermodynamic reaction. There are certain processes in thermodynamics which is adiabatic. Adiabatic means the energy will remain same. There is no exchange of energy. So whatever the energy of the system was cannot be exchanged to the surroundings, or energy cannot be taken from surrounding. So both that movement is not possible for energy. Then such kind of reaction of the system or the process is known as adiabatic. Adiabatic reaction.
Like an isolated system?
Yeah. In isolated system, matter is also not possible to exchange. It's like energy is conserved in some kind way. You can say energy is conserved for a system when it is in an adiabatic condition. It's not given out, it's not taken in. So energy is conserved. So you can say, anyway, I will define it little later. You will understand it when I will define it, because this is finally will lead to your law of conservation of energy only. Okay, so I just need this word meaning adiabatic process so that you will understand what is my explanation is. One more point is that in adiabatic process, temperature of the system may increase or decrease. Even though there is no heat exchange, but temperature may increase or decrease in some other way, some other means. That is possible. So in adiabatic reaction, heat exchange is not taking place, but a system may have an increase in or decrease in temperature. So Q is generally the term for heat in thermodynamics. Q stands for heat. So in adiabatic process, simply because those who are well versed after like by the end of this chapter, when you know everything by the terms and definition, adiabatic process mean in one sentence you can write delta Q is equal to 0, or you can say dq is equal to 0. That is the definition of adiabatic process. You don't have to define or write down the entire sentence. Adiabatic mean delta q or dq, change in heat, is equal to 0. There is no heat exchange, mean no change in heat for a system. That is why when you refer some books and all in adiabatic and all, like the system, the conditions mean they will not write it as adiabatic. They will just write delta Q or dq equal to 0. That means you need to understand that this is an adiabatic system or the process. Okay, so now let's look into my condition. Okay. It's changing over here, but it's not changing there. I don't know. Okay, so now only it came. Okay. Okay, I'll just reshare it. Maybe it will be better. Is my screen visible there? Like for those who are doing it remotely?
No, ma'am.
No, ma'am.
Okay, so this is problem with InstaShare. Just a minute. Just a minute, sorry. Boys, can you see my screen?
Yes, ma'am.
Okay, I think my white screen is visible there, right?
Yes, ma'am.
Somebody, okay, right, okay. So just let me know if you finish, if you lose any connection. Okay, just pay attention. Okay. So we check on our aim is like what we are going to do is like we have to check whether internal energy is a state function or a path function. So we define internal energy as sum of the or sum total of all the different stored energy, right? Like translational, rotational, etc. So now in order to prove that, okay, I'm taking a system where the wall of that container or the wall of the system, the boundary between the system and surrounding is adiabatic. That means the heat energy through this 0. Delta Q will be equal to 0 means delta Q is equal to 0 means through the wall the heat exchange is not possible, right? So let's say UA is the internal energy of the system at the start. U is the internal energy, A is just to show that it's a start, and the temperature is TA. So UA is the internal energy and TA is the temperature of the system at the start of the investigation, right? So now we have to discuss two different conditions. First condition, doing a mechanical work. Okay, so first condition, I'm going to do a mechanical work on the system, right? Where the internal energy is represented by UA and the temperature is represented by TA. So mechanical work is done mean using a paddle, just like turning, okay, whatever the system. So what is the after effect? So this is the initial condition. And after doing the mechanical work, the internal energy change to UV and the temperature is TB. Okay, so I'll just repeat. We took a system where the boundaries are adiabatic. That means heat change is not possible. And initially the internal energy is represented by UA and temperature is noted by TA. And after doing some mechanical work, that was the first condition, which was after that the internal energy changed to UV and temperature changed to TB. So they found that delta TB, delta T change in temperature, which is equal to TB minus TA, and delta U is equal to okay, there was a change in temperature TB minus TA after doing some mechanical work, and delta U is also changed from initial to the final, and we found that the final temperature or TB was greater than that of TA. That means the system there is a change in internal energy or increase in internal energy, or you can say increase in temperature has happened after doing that mechanical work, right? So this is the first condition. Mechanical work is done on the system. second case, so whatever the mechanical work is done, equal to that, same amount of energy is given in the form of electrical energy. It is given in the form of electrical energy. How can you give electrical energy in the system? How can you give electrical energy to system? How you will supply electrical energy? Say example, if your system is a glass of water, how you will supply electrical energy to the system? Yes, mean you will immerse electrodes in the system and you will pass the electricity, right? Yes, Harish?
Yes, ma'am.
Okay. So when the same amount of energy, whatever the energy you supplied as a mechanical work, the same amount of, let's say example 1 kilojoule was supplied as an electrical energy in a different, entirely different method or in the entirely different route. The same thing happens here also, and they found that delta U change in internal energy was same in both cases. So what we can prove over here, when you did a mechanical work on the system, there was a change in temperature, there was an internal energy change, and the same amount of energy you supplied in an electrical energy form by immersing the electrode. In that case also, the change in internal energy was same. That means internal energy is the
State function.
state function, because it does not depend how you supplied in the form of a mechanical work or in the form of an electrical energy. How you are supplied does not, how much, like it was equal to 1 kilojoule. So for that 1 kilojoule energy supply, like the form, whether it's a form of a mechanical or electrical energy, the change was equal. So mechanical, you are supplying as a mechanical energy or you are supplying as an electrical energy, it does not depend, it depends on how much you are supplying. So that corresponding change was happening for internal energy. So here what you can understand is like delta U, that is change in internal energy, is equal to work done under adiabatic condition. So internal energy change of a system is equal to how much work is done either in the form of a mechanical or electrical energy, whatever the different way, under adiabatic condition. Because the heat exchange is not possible, so it depends on the work done.
Ma'am,
So this is important trick you can find out over here.
ma'am,
Yes.
can you minimize the pop-up, the Teams pop-up in the right corner, bottom corner?
Teams, okay. Fine.
Yes, ma'am, fine.
Okay, so this is how you can show that internal energy is a state function, because we gave the same amount of energy as mechanical and electrical, whatever the work is done on the system, the change in energy was same. It does not depend on in what way you are supplied. Okay.
Now the mechanical work and electrical work, both of them
Mechanical work means it's kind of mechanical energy, right?
that mechanical work is an adiabatic process. Okay?
The system was under adiabatic condition. If it was not adiabatic condition, then your result won't be like exactly like, because temperature won't increase, maybe there was a heat exchange. So here, because of it's an adiabatic wall, the work you are done is directly increased as the temperature. Maybe if you're not maintaining an adiabatic condition, what will happen? maybe that temperature may exchange with the surrounding and you may not see a temperature change over there. Okay, anyway, just go through till this point. We'll continue our discussion. I think we have got one more period today. Yes. So we'll continue the discussion at that time.
Thank you, ma'am.
Okay, bye.
Thank you, ma'am.
Ma'am, a doubt.
Thank you.
Yes, Jonathan.
Um,
Somebody was there?
Siddharth,
Yeah.
and one,
Siddharth.
when do we have to submit the practicals? Is there a deadline?
Deadline is not given, right?
Oh, okay, ma'am. Thank you.
Okay, no, because I wanted it perfectly done. It's not like you are doing in hurry and you will commit a mistake. And there was some like were having doubts. I told them to wait, clear it and then write. Okay. Because anyway, this
Oh.
month we are not having practical, so you got a time to write it down. So before in December when we'll resume the practical, because this month it's for grade 12. So when we will resume, by that time we need to finish.
Okay, ma'am. Thank you.
Okay, bye.